In this video, we're going to look at how to contribute to the open acidification project, TankController. You can find this on github.com/open-acidification, and then we'll go select the TankController project. This project requires a few things in your working environment: a C compiler, Git, Ruby, and Python, along with the gem bundler. I have an environment already set up with those things in an online IDE. So I will set up that, and then I will get a clone address. And within this workspace, I'll open a terminal, and in that terminal, git clone paste. And that will clone the TankController project. Looking at the directory, we see examples, extras, source, and test. Once we have that, within the extras, there's a script for install libraries. So I'll cd into TankController and then run the install libraries script. That will install Arduino CI, which is an automated testing framework for Arduino applications or libraries. Then we'll install 8 libraries that we also use. Once that's installed, I'm going to run the automated tests. /extras, scripts, test, and build. That will start the Arduino testing framework. While that's running, we'll talk a little bit about the folders and files that exist in the project. An Arduino library comes with examples, and an Arduino application is a .ini file. Here we have a very simple INO file that has a setup routine that creates an instance of the TankController and calls the setup on that TankController, and then a loop function that calls loop, along with serial events that simply pass on the serial events. So this is a trivial INO application that simply passes on all the methods to the library. Our library is in the source directory, and it's made up of tankcontroller.h, which was included in the INO, as well as a .cpp file. So our .h file defines the class TankController, has a static method that returns the singleton of the TankController, then a few instance methods, as well as private variables and methods. The CPP file for the TankController includes variables to hold the singleton, methods to answer the singleton, a constructor to create the instance and do some initialization, including getting singletons for each of the required pieces, a destructor. We have a setup method that enables a watchdog timer so that if we're unresponsive for 8 seconds, it will restart. Then a loop function that is one of the 2 public instance functions. It's called repeatedly by the board. It appears to be about every 15 milliseconds, depending on how long the loop takes. We reset the watchdog timer, blink an LED on the device, handle UI, update the controls, record data to the SD and serial, record data to Google Sheets, process Ethernet communication, and then handle any HTTP requests. So this is the general events that happen in the main portion of the program. Within this, we also have a series of device controllers. We have something that interacts with the clock, the EEPROM, the Ethernet board, an Ethernet server, a keypad, liquid crystal. We have a controller and a probe for the pH, a controller and a probe for temperature, something that interacts with the SD card, and something that interacts with the serial port. So these are the general device controllers. We also have a directory for UI state, where we manage the main menu and then each of the things that can be done from the main menu, such as examine the time, set the calibration, set the pH, and see the tank ID, see the current pH, and so on. So these are the different UI states that the device can be in. We also have a few utility functions that handle such things as string copy, converting a float to a string, converting a string to a float, and some debugging interaction. We have a number of automated tests, and this is showing that the automated tests are running. By running the tests, you verify that you have a good environment and that things are set up properly for you to start doing development. After we finish running the automated tests, it goes through and builds the code using the Arduino compiler instead of the C++ compiler on our local machine. The C++ compiler on the local machine is used to run the tests against a mock Arduino board. And here we see that we have our 0 failures and an appropriate amount of free space left.